In the last 300 years, we have discovered the laws that govern the universe in all but the most extreme conditions. I think there is a reasonable chance that we may find a complete set of laws by the end of the century if we don't blow ourselves up first. If we do find a complete unified theory, it will be a great triumph, not just for scientists, but for ordinary people as well. In time, the unified theory would be simplified and taught in schools, at least in outline. Then, everyone would have some idea of how the universe works.
Now, Carl Sagan, you wrote an introduction to the book, and one of the striking things that you said is that it's only children nowadays who ask the big questions because they don't know enough not to.
What I was trying to get across was the notion that the school systems, it seems to me, have a attitude of discouragement of asking fundamental questions. If a 5 or 6 year old asks why the moon is round or why grass is green, the usual adult answer, at least in my experience, is to discourage the child. Say, what shape did you expect the moon to be? Square? Or what color did you expect the grass to be? Blue? Instead of saying that those are interesting questions, let's try to find out the answer, or maybe nobody knows the answer, and when you grow up, you'll be able to discover the answer. It would be very healthy for the human species if there were less discouragement and more scientists.
Arthur Clarke.
One of the reasons why I write science fiction is because it does free the imagination and does inspire people to become scientists and astronauts. Many astronauts have made me feel a very old man by coming up and saying to me, you know, your books turned me on when I was a small boy.
Excellent. Now, I have planned a reasonably finite structure for our little colloquium, and I'd like to start, if I may, with Professor Hawking. How did the universe start? With a Big Bang?
We observe that distant galaxies are moving away from us. This means that they must have been closer together in the past. In fact, one can show that all the galaxies must have been on top of each other about 15 billion years ago. This was a real Big Bang, not a puny thing that took place on the stock exchange a couple of years ago. It was the beginning of the universe and of time itself. Anything that happened before the Big Bang could not affect what happened after. So we can neglect events before the Big Bang and say that time began at the Big Bang. After the Big Bang, we believe that the universe expanded in a very rapid, inflationary manner. Again, this inflation in the universe quite puts modern economic inflation in the shade. An increase of billions of percent in a tiny fraction of a second. Of course, that was before the present government. During the inflationary period, the universe borrowed heavily from its gravitational energy to finance the creation of more matter. The result was a triumph for the economics of Keynes. A vigorous and expanding universe filled with material objects. The debt of gravitational energy will not have to be repaid until the end of the universe.
Well, I'd like to stay with this basic proposition for the time being, the Big Bang theory. And to come to you, Carl Sagan, could you help me by putting into layman's terms what was involved with this Big Bang?
Well, here we are on a planet which is about 5,000 million years old. The sun around which it goes is not much older. It is part of a galaxy which is perhaps 10 or 12,000 million years old, which is one of perhaps hundreds of thousands of millions of other galaxies. And none of this, planets, suns, galaxies was around at the time of the Big Bang. At the time of the Big Bang, there was energy, elementary particles, which slowly evolved into the kind of universe we know today. We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware. One of the great accomplishments of Dr. Hawking is to plug us better in to the knowledge of this long evolutionary sequence.
Idea in Professor Hawking's book, this extraordinary four-dimensional model of the universe with no boundaries, but finite, just like the Earth. This, to me, is really stretching my own capacity for imagination to the utmost. How would you turn it into words for me, a layman?
Well, the first thing I would say is not to feel bad if it's not immediately intuitively obvious. Our ability to understand things instantly, so-called common sense, derives from a certain range of size and speed and duration that are appropriate for human existence. We know about things from a tenth of a millimeter to a few kilometers, from a fraction of a second to a lifetime, and so on. So when we are dealing with matters of quantum physics, where particles have a size of 10 to the minus 13th centimeters, or in cosmology, where we are talking about 10 billion light years or more, it is very reasonable that our intuition is not adequate to the task. One point I'd like to make about this is that every human culture has a set of creation myths, but they're in the realm of mythology or religion or folklore, and they are, of course, all mutually inconsistent. The great thing that is happening in our time is that we are able, through a method which can actually make some progress towards the real universe out there, to find out something about origins, and this is the scientific method applied to the science of cosmology. So I know that's not a direct answer to your question, but I thought it was more important to address the issue of feeling unhappy because it wasn't immediately understandable.
Well, yes, I find that extremely soothing, actually, because it is a kind of sort of formidable task of grasping this. It makes me want to retreat into trivial questions like, is this idea of predicting backwards going to put astrologers out of business?
Nothing will put astrologers out of business.
Well,
Alas.
Now, Professor Hawking, in the very last paragraph of your book, you say that if we discover a complete theory of the universe, then it should in time be understandable in broad principle to everyone and not just to a few scientists. And when that happens, all of us will be able to start discussing the why rather than the how. And I quote, "If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God." Do you think that God can intervene in the universe as he wants, or is God too bound by the laws of science?
The question of whether God is bound by the laws of science is a bit like the question, can God make a stone that is so heavy that he cannot lift it? I don't think it is very useful to speculate on what God might or might not be able to do. Rather, we should examine what he actually does with the universe we live in. All our observations suggest that it operates according to well-defined laws. These laws may have been ordained by God, but it seems that he does not intervene in the universe to break the laws, at least not once he had set the universe going.